So let's solve the problem. So we want to test whether this function is harmonic. So u of xy is harmonic if and only if partial squared u partial x squared plus partial squared u partial y squared is 0. So that's what we need to test, that the sum of the second partial derivatives of the function with respect to x and with respect to y sums to 0. So you see our problem. So here, u of xy is given by e raised power minus 2xy sine of x squared minus y squared. Now, because these are product of two functions, to get the derivative, so let's call this one u, call this other part v. By product rule, we have u prime v plus v prime u. So partial u, partial x. Derivative of this function with respect to x. First, we use chain rule and differentiate this power with respect to x. So we get minus 2y, and then e raised power minus 2xy multiplied by sine of x squared minus y squared. And then plus derivative of this function. So the first we differentiate this bracket, we get 2x. Derivative of cosine, sine function is cosine. And then we multiply by this e raised power minus 2xy. So when you factor out e raised power 2 minus 2xy, partial u partial x will be 2x cos of x squared minus y squared minus 2y sine of x squared minus y squared. All this you multiply by e raised power minus 2xy. So next, we differentiate this same function with respect to x. So partial squared u partial x squared will be now this part here, I want to let all this square bracket to be my u and this one to be my v. So u prime, differentiating this one, also this part I have to use product rule twice. So this will give me 2 cos x squared minus y squared, and then plus, but there will be minus because I have to differentiate this one. So it'll be 2x derivative of this part, and then times this 2x, and then cos function will differentiate to get sine function. And then, so I'll have done the derivative of this part, then plus or minus. So derivative of this function here with respect to x, because this is the only term that has an x, so derivative of this one will give me 2x. I'll have minus 2 by 2 is 4 xy, and then cosine of x squared minus y squared. And then I multiply this one by e raised power minus 2 xy. Then the derivative of this one will give me minus 2y e raised power minus 2xy. Then I multiply by this bracket 2x cosine of x squared minus y squared, and then minus 2y sine of x squared minus y squared. So this will give me partial squared u partial x squared. So we factor out e raised power minus 2xy. And then you see at this point here, I can start with this minus x, 4xy cos of x squared minus y squared. So I've written this term. And then next plus 4 so this we have okay, so let's just start by the first one on the left. So we have so after factoring out e raised to minus 2, so this first term will be 2 cos of x squared minus y squared. Here I'll have minus 4 x squared sine of x squared minus y squared. Here I have minus 4 xy cos x squared minus y squared. And then you have a minus sign here. So this 2y by this one, I'll get minus 4 xy cos of x squared minus y squared. And then minus is plus. So 4 y squared sine of x squared minus y squared. So that's what I have as my partial squared u partial x squared. So then we can put like terms together. Say partial squared u partial x squared is given by e raised power minus 2xy into 2 cos x squared minus y squared. Now, say this and this will have minus 8xy cosine of x squared minus y squared, and then minus 4 x squared sine x squared minus y squared, and then plus 4 y squared sine x squared minus y squared. So that's the expression for the partial squared u partial x squared. And then remember u is given by e raised power minus 2xy and then sine of x squared minus y squared. So let's start now getting partial derivatives with respect to. So let's call this one actually equation 1. So partial u partial y also use product rule. So taking this one as my u, this one as my v, derivative of this part with respect to y will be minus 2x e raised power minus 2xy, then I multiply by this sine of x squared minus y squared, and then derivative of sine is cosine, but this part when you differentiate with respect to y, you get negative 2y, and then e raised power minus 2xy, and then cosine of x squared minus y squared. So I can factor out e raised power 2xy. This will give me minus 2x sine of x squared minus y squared minus 2y, and then e raised power. Okay, so actually I can put out that that 2, because it happens to be on every term. So factoring out 2 e raised power minus 2xy, then I'll have minus, or let me factor out the negative. So all the terms in the brackets will be positive, so that my partial u partial y will be minus 2 e raised power minus 2xy, and then x sine of x squared minus y squared plus y cos of x squared minus y squared is what I'll have in the brackets. And then I also use product rule again. So partial squared u partial y squared. So this with respect to y, I'll get now 4x e raised power minus 2xy into x sine of x squared minus y squared plus y cos of x squared minus y squared, and then plus, then this derivative of this function with respect to y, this first part I'll get minus 2xy, and then cosine of x squared minus y squared, and then plus this part here I use product rule, so I'll have cos of x squared minus y squared, and then minus derivative of cosine is minus sine, and then this one will be minus. So I'll have minus, then y, and then sine of x squared minus y squared. But then I multiply by the derivative of this is minus 2y. And then you multiply this by negative 2 e raised power minus 2xy. So which will be factoring out e raised power minus 2xy will give you, so 4x by this I'll get 4x squared sine x squared minus y squared. 4x by this I'll get plus 4xy cosine of x squared plus y minus y squared. So 4xy cosine of x squared minus y squared. And then there's a negative sign here. So negative times negative plus. So plus 4xy cosine of x squared minus y squared minus 2 times this. I'll get now minus 2 cosine of x squared minus y squared. And then minus minus is plus. So I'll have 2. I remember here, I'll have this minus and this minus is plus. So this minus will now give me a minus sign. So I get, remember y times 2y is 2y squared, then by 2, so it'll be 4y squared sine x squared minus y squared. So okay, so this the sign here, so this is minus 2y, and then we had minus, okay, that's fine. So then now, call this one equation 2. So 1 plus 2. So we'll have partial squared u, then plus partial squared u partial x squared partial y squared. Now let's just now see the term in equation 1. So we have 2 cos of x squared minus y squared is positive, and here in this equation 2 is negative. So these two terms will cancel out. So we'll not have a cos function in the function. And then minus 8xy, but here we have, okay, so let's this, when you simplify, you'll have e raised power minus 2xy into 4x squared sine of x squared minus y squared. This plus this will be 8 of them. Now positive 8xy cos of x squared minus y squared. And then minus 2 cos of x squared minus y squared. And then minus 4y squared sine of x squared minus y squared. When you add this equation and the equation 1, you should actually get 0, because similar terms in these two equations have opposite signs. For instance, you see here, this one has positive sign, 2 cos, and then here, this one has a negative sign. So we have done with terms of this kind, minus 8xy, but here we have positive 8xy. So adding those two eliminates those terms. Here we have minus 4x squared, while here we have plus 4x squared. So you'll have, adding those two, you have eliminated this term, and then plus 4y squared, while here we have negative 4y squared. So also the sum of those terms will give you 0. And so 0 times e raised power negative 2xy gives you 0. And that's how you are supposed to prove that. Thank you.